very last video on our practice assessment is the scatter graph. So we're given time and speed, and we have to draw our scatter graph. And all that means is draw these points. So we can see on the graph that time is on the x-axis and speed is on the y-axis. I'm just going to plot all these different points. So there's 0, 0, that's the first one. The next one at time 2, we've got 10. So the only thing you can maybe get caught up with is just checking your scales. So here the scales are 1 for every box, and then here it's 10 for every box. The next one is 6 and 50. Plot that. And then 8 and 60. 8 and 60. And then 12 and 80. And 16 and 110. Okay, so we've got a series of points we've plotted, and the question was a best fit line. So all that means is, let's try, obviously we can't quite draw a line between all of these because they're not quite y is equal to x. Yeah? But we can draw a best fit line. I think that looks half decent. So there's 2 just above the line, 2 just below the line. But yes, obviously the point is this would obviously not be right. This would not be right. You're looking for something that has all the points as close to the line as possible. So it's like the line representation of an average. Yeah. So to me that's looking not bad. And we're going to use our graph to estimate speed after 4 seconds. So this is the speed of a car accelerating from rest. So after each time, it's where the speed the car goes at. So after 4 seconds, what do we think the speed's going to be? So we just go up to our graph. There's 4 seconds. So I would suggest that that's going to be about 30 miles an hour. And if a car was travelling at 70 miles an hour and was estimated to be accelerating for 10 seconds, is this reasonable? So let's see, where's 70 going to be? There's 70. That meets the line here. So yeah, I'd say that is reasonable, yes. Because we're seeing 70 and 10. If we looked at our graph and that number was more like 12 or 8, I'd say no, it's not a very reasonable estimation. But anything close to this looks good. So that shows we've probably done quite a good line of best fit on there as well. So if you don't do your line of best fit properly, your next few questions won't be quite right. But it really is as simple as that. Very straightforward. All we're doing is plotting these numbers and then drawing our kind of an average, a line that represents an average of these numbers. Okay, so don't. That's obviously not a best fit. That's not a best fit. It's somewhere up the middle, where anywhere from around about here would be pretty fair, I think. So it's like a visual representation of the average, and then we're just reading off the graph. So watch your scales. Take your time to draw the best fit, and then we're just reading off. That is the end of this paper. Like I said before, that's the Dalkeith High School one. There are 2 other papers that are very similar, and the marking schemes are at the end if you're interested in seeing the marking scheme. So I could just scroll down just to show you what a marking scheme looks like. These different points here are each of your marks. So it's quite comprehensive. That was our last one there with the best fit line. So yeah, pretty close to what it has really. But you can see where you get all your different marks from. And sometimes they will say, for here, for example, for the angles, show the working, you get a point for that. So if you just write down the final answer, you might not get the mark for it. As time goes on, these things get amended, so people might put a note in to say that's fine. But in this type of marking scheme, it doesn't say. It does say explicitly just this, so you would expect to only give the mark if the working's there. The point is, I would just show as much working as possible. So that's the marking scheme. You can have a look at that. Well, that's been helpful. That's paper 1 done. And at some point, I'll go on and complete paper 2 and paper 3. So thanks very much for listening. Hope that was helpful.